Hello everyone! Today my team and I will be presenting our analysis on airline customer satisfaction. We'll be covering our analysis and findings in 8 parts. So, about airline customer satisfaction. Why does it matter? Customer satisfaction is crucial for airline loyalty and business success. Therefore, the goal is to find out what really matters to the customers. These insights can help airlines focus on improving the areas that make the biggest difference. To achieve the goal, we use 4 models: logistic regression, decision trees, neural networks, and random forests. Before we dive into the models, let's take a quick look at the data we use to understand customer satisfaction.
Let's start with a quick overview of the dataset. We use the airline passenger satisfaction dataset from Cargo. The dataset contains 25 columns and includes features such as passenger demographics, travel details, service rating, and the satisfaction level. In our case, the target variable is satisfaction, which indicates whether the passenger was satisfied or rather neutral dissatisfied. We also notice that there are some missing values for the arrival delay in minutes. Therefore, in order to prepare the data for modeling, I perform the following key cleaning steps. First, delete the 2 columns unnamed zero and ID from the original data DF so that the remaining variable are valid features that can participate in modeling. Then we handle the missing value. There was 393 missing value for arrival delay in minutes, which we filled with the main of the column to preserve the data size. Next, we encoded the categorical variables. The satisfaction column was converted to binary, 1 for satisfied and 0 for neutral or dissatisfied. Other categorical fields such as gender, class, and travel type were one-hot encoded, and the first value of each category was automatically deleted to avoid the dummy variable trip. Next, we need to perform train test split, remove the target variable satisfaction from the entire data div to get the final feature variable matrix, and take the satisfaction column as a target variable, which is what we will predict next. Finally, we applied standard scaling to the numerical features. This ensures that variables such as age, flight distance, and service rating are on the same scale, which helps improve model performance. After these steps, the datasets are clean and ready for modeling.
After the data cleaning progress, we trained a logistic regression model using the original dataset without any parameter tuning or regularization. The model achieved an accuracy of 87.5% and an AUC of 0.926, which indicates good performance in distinguishing between satisfied and dissatisfied passengers. However, to further enhance the model's generalization ability, we applied L2 regularization and performed data balance techniques to address the class imbalance. The revised model achieved an even more stable performance with similar AUC and improved recall for the minority class. This indicates that our optimization improved the model's robustness and ensure more reliable prediction among different passenger types. After confirming the model's predictive performance, we turn to interpretally to derive actionable business insights. By examining the logistic regression coefficients, we identify the top service factors that contribute to passenger satisfaction, most notably online boarding, inside Wi-Fi service, and check-in service. On the other hand, features such as personal travel, disloyal customer, and the economy class are associated with lower satisfaction. These findings suggest that the airline should invest in digital service improvements and targeted loyalty strategies, especially for leisure and economy passengers. Overall, our model not only provides strong predictive accuracy, but also deliver a clear strategy guidance for enhancing customers' experience.
So, why decision tree model? The decision tree model is a powerful tool because it handles both categorical and numerical data well. Specifically, its ability to break down data based on different variables in an intuitive way makes it easier to identify the factors that have the most impact on customer satisfaction. From a business perspective, Decision Tree offers several key benefits that make it even more valuable. It is easy to interpret, It helps identify key factors and it improves decision making. Here, we have the initial decision tree model. At the root, we can see that online boarding plays a critical role in determining customer satisfaction. If a customer rated online boarding poorly, specifically with a rating of 3.5 or lower, most of them turn out to be dissatisfied. The tree then splits into features like in-flight Wi-Fi and travel type. For example, individual travelers who also rated Wi-Fi poorly were more likely to be dissatisfied. Through the decision trees, we can easily find the significant factors that affect the customer satisfaction. However, its complexity poses a problem, the risk of overfitting. So next, we will apply pruning to refine the model. As you can see, we prune the decision tree to reduce overfitting and improve efficiency and interpretability. This simplifies the decision tree while retaining key features such as online boarding, in-flight Wi-Fi, and travel type. The prune model removes less significant nodes and improves generalization, making it more suitable for real business use.
I like to share my work on building an artificial neural network model to identify the key factors influencing airline customer satisfaction. I first built a preliminary model and it performed extremely good. To further improve its performance, I carried out hyperparameter tuning. For the optimized model, I use the IBFGS solver, logistic activation, a single hidden layer with 9 neural, and a learning rate of zero point 0.1. With this adjustment, the AN shows a significant improvement, especially in identifying satisfied customers. This accuracy increased from 93% to 95%, and the precision improved from 93% to 96%. This indicates the model became more accurate and reliable for real-world application. I also use feature importance to explore the key drivers of satisfaction. The most critical feature is in-flight Wi-Fi service. Given the growing need for connectivity, airlines should invest in improving Wi-Fi quality and availability, especially on long-haul flights. Another key feature was type of travel, particularly for individual travelers. Airline can offer more leisure-oriented services, such as friendly service atmosphere, which improve satisfaction and encourage rapid business. Additionally, loyal customer satisfaction is critical to retention. Airlines should focus on rewarding loyal customers through exclusive benefits such as upgrades and priority service. This approach increases customer loyalty and drives positive word of mouth.
Then let's talk about the random forest model. The model achieved 97.1% accuracy on the training set, showing it learned the data well. However, we remain cautious about overfitting. The test accuracy is also high at 85.81%, indicating good generalization to unseen data. The recall is 97%, meaning the model identified almost all dissatisfied passengers. Precision is 95%, showing few misclassified customers, a mineral trade-off in this case. The confusion metrics support this, with most value on the diagonal reflecting strong prediction accuracy and low error. Overall, this model is powerful and reliable, effectively predicting customer satisfaction based on service-related features. Previously, we used the decision tree model. Due to higher accuracy of the random forest, we verified feature correlations. The strongest positive correlation is with online boarding, which is zero point 0.5, showing a close link between digital boarding and satisfaction. Other features like in-flight entertainment, seat comfort, and cabin services show moderate positive correlations, which is zero point 0.3 to zero point 0.4, suggesting a consistent link with satisfaction. On the negative side, personal travel and economy class show a correlation of negative 0.45, meaning lower satisfaction is more common in these groups. Flight delays shows only a slight negative correlation, and age has a small positive one, suggesting older passengers may rate their experience slightly better. These results are consistent with the decision tree but more accurate, supporting our final recommendations.
In terms of model comparison, according to the classification report, both random forest and artificial neural network show the strongest performance. Not only did they achieve 96% accuracy, but they also maintained an excellent balance between precision and recall. This suggests that they are not only highly accurate, but reliable in identifying both satisfied and dissatisfied customers. The decision tree model showed good classification ability with a accuracy of up to 90%, clearly distinguishing between the two categories. The logistic regression maintained a stable and balanced performance, which is particularly important when dealing with balanced dataset.
Further analyzing the model performance of the confusion matrix, AN and random forest show excellent structure. The number of true positives and true negatives of those two models is significantly higher, indicating that they are very good at identifying satisfied and dissatisfied customers and have strong generalization ability. The overall performance of the confusion matrix of logistic regression and decision tree models is relatively balanced. However, the number of false positives and false negatives is significantly higher than that of AN and random forest, indicating that although those two models have certain predictability, they also have some misjudgment. Overall, if predictive performance is the primary goal, random forest and neural network are better choices. In contrast, the decision trees and logistic regression have misclassifications, but the overall predictive performance is still more reliable, which is suitable for scenarios with higher requirements for model interpretability.
Beyond strong model performance, this project offers actionable insights with significant strategy and operational value to the airline. First, the model identified digital service quality, particularly online boarding and in-flight Wi-Fi, as the most influential drivers of customer satisfaction. This suggests that the airlines should invest in digital transformer efforts, including use interface optimization and automation of service touchpoints to enhance the overall travel experience. Second, we suggest the airline to improve on-time performance, strategy adjustment in boarding gate assignment, flight schedule, and airport logistics can help reduce delays and mitigate dissatisfaction. Most importantly, our model enable early intervention with over 96% accuracy in detecting dissatisfied passengers. Airlines can proactively identify high-risk individuals and apply personalized actions, such as compensation or loyalty rewards. These steps not only reduce churn but also strengthen customer trust. Altogether, the project helped shift several management from reactive to predictive, building a long-term data-driven strategy for improving customer experience and competitive positioning.
This part is for conclusion. To conclude, we built the compare four models. Among them, random forest and annual artificial neural network show the best performance with high accuracy and balanced prediction, making them suitable for future use. While logistic regression had a lower accuracy, it provided a strong interpretability which is helpful for feature analysis. The decision tree, however, was overfitted and not reliable without further training. From business perspective, the model helps identify dissatisfied customer early and guide improvements in Wi-Fi, check-in, and seat comfort. In the future, we suggest testing model like XGBoost and put this system in real time for continued feedback and optimization. Thank you for your listening.